Okay, good morning, guys. This is the test review for the Unit 1 test. I'm having this in Canvas, so make sure you go through it if you need to for your notes. Algebra 2 Unit 1 assessment review. If you are given the function f of x equals 4 times the difference of x and 7 plus 3, find the function that represents, and it says f of negative 1 of x. This means the inverse of f of x, okay? So I'm going to write it here, what it means. This right here, that means the inverse of f of x, okay? It means the inverse So practically, you're looking for the inverse of this function. To do that, I would recommend that you clean this function first. So notice that this is a linear function, so you could do 4 times x and 4 times negative 7. So you would have f of x is equal 4x minus 28 plus 3. Negative 28 plus 3, that's a subtraction. 28 minus 3, which is 25. So that's 4x minus 25. So that would give you this. Now I would start. The first step is to change the f of x for a y. So change that to a y. Then switch the x and the y. So x equals 4y minus 25. Solve for y. So x plus 25 equals 4y. Then divide by 4 on both sides. So x plus 25 divided by 4 is equal to y, because 4 divided by 4 is 1, so it's y. So basically I could put it in inverse notation, or function notation, I'm sorry, equals x plus 25 divided by 4. Remember, you want to check if this is the inverse of that. So you want to create two tables of values. Okay, so I'm going to create two tables of values, one for the first. So let's say it's 1, 2, and 3. So let's say x is 1. So 1 minus 7 is negative 6. Negative 6 times 4 is negative 24. Negative 24 plus 3 is 21. So I go again. What if it's 2? Well, 2 minus 7 is negative 5. Negative 5 times 4 is negative 20. Negative 20 plus 3 is negative 17. Then what if x is 3? Well, 3 minus 7 is negative 4. Negative 4 times 4 is negative 16. Negative 16 plus 3 is negative 13. Okay, so now that I have that table of value, I go here and I enter the outputs in the inputs of the other functions. So 21, negative 17, negative 13. And I see what my output, I'm expecting 1s, 2, and 3. That's what I'm expecting. So my question mark 1, 2, and 3. Well, let's see. If this is 21, oh, it should have been negative. I'm sorry, negative 21. If this is negative 21, negative 21 plus 25 is 4. 4 divided by 4 is 1. There it is. If it's negative 17, then you have 25 minus 17. You have 8. 8 divided by 4 is 2. If this is negative 13, so you have 25 minus 13, that would be 12. 12 divided by 4, that is 3. Now, I wanted to show you that you could do this on decimals. So if you don't know how to do it, hey, I learned this the other day myself here. I'm going to enter the first function, 4x minus 7 plus 3. So that's what I'm going to enter. So 4x minus 7 plus 3. Okay, once I have that, I'm going to enter my inverse function. My inverse function is x plus 25 divided by 4. So I'm going to enter that here. I put the division sign, and I think it's x plus 25 divided by 4. X plus 25. Now, what you want to do is notice right here, you could see already, if you remember that they are reflections across the line y equals x, then all you have to do is put here y equals x, and you could see that it goes right through the point of intersection, so you see they are reflections. So I know right there and then it's already known they are inverses. If you want to create a table, take a look. To create a table, just hit the plus sign, add a table, take this right here, and instead you want to put this function. So copy this function by putting Control C, and then go here, Control V. So once it's there, put the values 1, 2, 3, and then go here. Notice it doesn't, nothing happens, but this is x sub 1. There is a 1 right, which is under. So I'm going to go to that x and put 1, and notice what happens. So it gives me the values negative 21, negative 17, negative 13, which is what I had here. Okay? Now, what I want to do is I want to create another table and compare those two tables. So I'm going to go here. I'm going to add a table. And this time I'm going to use that second function, which is this one. I'm going to copy it. I'm going to paste it over here. And then put the outputs, negative 21, negative 17, negative 13. So negative 21, negative 17, negative 13. And then here, notice this is x sub 2. I'm going to go there and put a 2. And notice the expected outcomes are there, 1s, 2, and 3. So that means, notice that your two tables are flipped, therefore they are inverses. And that's how you test it. Okay? So let's go to the second one. Try the second one on your own. Pause the video, try the second one, and see if you come up with the right answer. All right, here we go. First thing I like to do is to clean it a little bit. So I'm going to do 5 times x, 5 times negative 2. So that's 5x minus 10 plus 7. That's 5x minus 3. So f of x is equal 5x minus 3. At that point, then I want to find the inverse. I start by substituting f of x for y. Switch the x and the y. Solve for y, so x plus 3 equals 5y divided by 5, so x plus 3 divided by 5 is y. So that means the inverse of f of x equals x plus 3 divided by 5. Now all I have to do is create a table of values like I did before and check, and do that on calculator if you like, or you could do it manually. But then all you're left to do is create the tables, okay, right here. So it says 1s, 2. I'm just going to do 1s and 2. So 1 minus 2 is negative 1. Negative 1 times 5 is negative 5. Negative 5 plus 7 is 2. All right, if it's 2, 2 minus 2 is 0. 0 times 5 is 0, plus 7 is 7. So I got 2 7, so I'm going to put it here. 2, 7. The expected outcomes are 1 and 2. So I go here, and I plug in my 2. 2 plus 3 is 5. 5 divided by 5 is 1, so that is good. If it was 7, 7 plus 3, 7 plus 3, that's 10. 10 divided by 5 is 2. And there you have it. So I've checked that very quick. Move to the third one. On the third one, they are asking me f of x equals negative 2/3 x plus 1. Which of the following is the inverse function? Okay, if I was you, I would give values to these, right? I'm going to show you both ways. I would give values, and I would do it on decimals. I would go to my calculator, and here we go. Let me go to the calculator. Let's erase the ones we had before. And let's look. It's negative 2/3 x plus 1. So negative 2/3 x plus 1. Okay, so there it is. I want to do the table for that. So I add a table. I'm going to take this function. I'm going to copy, Control C. I'm going to go here, erase that y sub 1, and press Control V. Now, for the x, go close to the x and put a 1. And now, I'm going to use a couple. So 1, 2, 3. Hey, I'm looking for the ones that give me good numbers. Look, 5, 6. So 3, negative 1, 6, negative 3. These, I wouldn't use those because they're hard for you to test quickly. So I'm going to build my table, and it would be x and y, 3, negative 1. So let's do that. And the other one is 6, negative 3. Okay, so now that I have those two, I'm going to look which of the following is the inverse. So that means one of these must produce the inverse table or the table switch. So I'm going to put x and y because this is what I'm looking for. I'm going to put the outputs here. And now I'm looking for 3. And I am looking for 6. So I don't need that no more. I am looking here, so I don't want to get confused. I would use the calculator for that. Negative 1 times 3 is negative 3. Plus 3, that's 0. 0 divided by any number is 0. So my output is 0. I am looking for 3. That's no good. Same thing for here. 3 times negative 1 is the same thing, so that will still be 0. That's no good. Now I go here. 3 times negative 1, that's negative 3. Minus 3, that's negative 6. Negative 6 divided by 2, negative divided by positive is a negative 3. I'm looking for 3. Negative 3 is close, but no good. So it must be this one. Notice this is the same one here, so it's going to give me negative 6 divided by negative 2. Negative divided by negative is a positive, so that will give me my 3, which is the expected answer. So my answer is D. So there you have it. Moving on. The graph of function g is shown below. So they show you a graph. What would be the graph of the inverse of function g look like? Well, it has to look like the mirror of it across this line. So if that is true, that means it must look exactly like that. This doesn't look like it, this doesn't look like it, this doesn't look like it. Voila, it must be that one. Notice it's going to be down here like this. So it's a mirror of this one. All right, so D, number 4 is pretty simple. Number 5, oh, I already had it here. I'm sorry. What you have to do, it says the graph of a function is shown below. Which of the following coordinates is a point on the inverse function? Remember the table switch. So what I would do is those points right here, I would put the values, right? And notice negative 1, 8, 0, 3, 1, 0. Which one of these is here but backwards? Notice if I read them backwards, 8, negative 1. Is it here? Nope. 3, 0. 3, 0. Is it here? No. 0, 1. Is it here? 0, negative 3. No. Negative 1, 2. Ooh, here it is. So C is my answer. Okay, number 6. When verifying if two functions, f of x and g of x, are inverses, what must be true about the composition of these two functions? Remember this. In order for these two to be inverses, what must be true is that when I put g of x inside of f of x, that means if I say f of x or f of g of x must equal x, and g of f of x must equal x. If that is true, if these two things are true, they both equal x, then that means they are inverses, okay? So let's go to number 10 and I show you what we mean by that. Okay, so number 10, use composition of functions to determine whether the functions are inverses. Notice f of x over here. I'm going to do this one. I'm going to try it. Okay, so notice f of x is 2x minus 9 and g of x is x divided by 2 plus 9. I want to know if these two are inverse functions. Well, I'm going to say, well, f of g of x. Notice that f of x is 2x minus 9. So I'm going to put 2 parentheses because that x is going to be substituted for g of x minus 9. And for x, notice the 2x minus 9, 2x minus 9, 2 blank minus 9. I'm going to put x divided by 2 plus 9. So x divided by 2 plus 9. I'm going to solve this and see if f of g of x is x. Well, remember, to solve that, all you have to do is multiply. Remember, distribution. So 2 times x divided by 2, the 2 cancels. It gives me that is x. 2 times 9, that's 18, minus 9. 18 minus 9 is 9. So this is x plus 9. So this is f of g of x equals x plus 9. Remember, we said before that in order for them to be inverses, they would have to be f of g of x equals x. In this case, f of g of x is x plus 9. So we have to say these two right here, they are not inverses. Now, let's check the other one. The other one, it says f of x is blank x minus 3 divided by 4. So I'm going to put blank minus 3 divided by 4. That blank, I'm going to substitute it with g of x, which is 4x plus 3. I'm going to solve that. Notice the parentheses cancels out, so nothing to do there. So I'm just rewrite it. 4x plus 3 minus 3 divided by 4. 3 minus 3 is 0, so that's 4x divided by 4. 4 divided by 4 is just 1, so that's 1x. So that means f of g of x equals x. So that's good so far. Now I'm going to check the other one. I have to say then that g of f of x must also equals x. So let's write g of x. G of x is 4 blank, 4 times blank plus 3. Notice the blank is going to be f of x. F of x is x minus 3 divided by 4. I'm going to solve that. Notice these 4 cancels, so it gives me that this 4 cancels. It gives me x minus 3 plus 3. That means negative 3 plus 3 cancels. That equals x. So g of f of x equals x. Therefore, these two, they are inverses of each other. Okay? Okay, so let's move back to number 7. Number 7, which table is the inputs and outputs of the inverse of function f of x, which is 5 raised to the x power? Okay, so basically all I want to do is find the table for this function, and remember that the tables do what? They flip. So that's what I am looking for. I'm going to go to Desmos quickly. I'm going to erase what I had there before, and I'm going to put my function 5 raised to the x power. So 5 A over B, oops, sorry about that, is 5, then raised to the x power. There it is. Now I want my table. My table, I just add, and I am going to copy this. Put a 1 there. And now I'm going to use these numbers. -2, -1, 0, 1, 2. There you go. Okay, once I create the table, what I want to do is write it down. So it's the x and y, right? Notice 1 is 5, 2 is 25. Now, I'm not looking for that. That's not the one I'm looking for. I am looking for the one that is backwards. So I'm going to write it here. So x and y, when I have 0.04, I should get -2. When I have 0.02, I should get -1. When I have 1, I should get 0. When I have 5, I should get 1. When I have 25, I should get 2. So now that I have that, I want to look over here. And I see that 0.04 is not there, so it should be, okay, did it give me 1? It's -2, -1, 0, 1, 2, 4, 1, 0, 5, 1, 25, 2. That's my answer. See how simple that is? Okay, moving on. What is the domain and range of these functions? Well, I'm going to show you how to write the domain in different ways, okay? So this is just a review. We already went over this. The domain of a parabola, remember domain, we're looking for it in the x right over here. So I want to know how far to the left and how far to the right does it go. Notice the parabola keeps going to the left and it keeps going to the right forever. So that the domain will be all real numbers. So x is an element of the real numbers. Or you could write it in set builder notation, x such that x is an element of the real numbers. Part of my writing. You could write it in, let me see, interval notation, which would be what? Negative infinity to positive infinity. And that would be interval notation. As a graph, it would look like this. All of it, right? All of it. That's all real numbers. The range, however, I'm looking for the range in my y-axis. So notice it goes down to here and then it moves up forever. So it goes that way. So now that I know that, I could write the range. The range for this function it would be y that is greater than or equal to -1. So y is greater than or equal to -1. You could write it in set builder notation. So you should know all of them because they might ask you to write all of them. So y such that y is greater than or equal to -1. So it goes from -1 inclusive, so bracket, -1, and then it goes to infinity. The graph would look something like this. And it starts at -1. Remember, closed circle, -1. And then it goes to infinity, so it's unbounded. So it goes like that. Okay? So that is the graph. Now let's look at the next one. The next one right here, what is the range? The range, the domain and range of this function. For the domain, I'm going to write my domain right here. Remember, it's my x-axis, so it goes from here to here. However, this circle is open, so I'm going to put a big open circle, and then it goes to here. Notice my graph already here. All right, so in set builder notation, my domain, it would be x such that x, okay, I'm sorry, in set builder notation, remember this x is between two numbers. In this case, it's 2 and 7. So x such that, x such that x is between 2 and 7. However, this 2 is not included. It's not included. So I'm just going to put x is greater than 2, but yet is less than or equal to 7. So that is in set builder notation. Remember, this 2 is not included. In interval notation, that 2 will be this way, and the 7 will have a bracket. Okay, so that's the two ways. How to graph it? Well, here's the graph. Basically, if you did what I just did, I have an open circle at 2, a closed circle at 7, and I would shade this between that, right? All right, so that is that, guys. That is that. That's the domain. Now, let's look at the range. Let me change colors for the range. The range, in this case, remember, we're going for the y. I want to see how high this goes. Notice a closed circle right here. So I'm going to move that closed circle to here. And notice down all the way to here, and it's closed. So I'm going to move a closed circle to here. Notice my graph already showing. Okay, it goes from -5 to -2. So from -5 included to -2 included. That means x is greater than or equal to, this is -5, go in the left or on the left, and then -2 over here, right? And you could say y such that, or it's not x, it's y, such that y is between -5 and -2 inclusive. To graph it, the graph shows right here already. All I have to do is draw me my line, my -5 and -2, and they're both closed circles, so closed circles and a shade in between. So that's it. That's what you need to know as far as that. Then one last question here. It says, list the x-intercepts, y-intercepts, axis of symmetry, and vertex of these functions. Well, let's see. The x-intercept would be where the x touches the x-axis, where the graph touches the x-axis. In this case, is at 1, 0, and 3, 0, right? Those are my x-intercepts. Sometimes you could say it's 1 and 3. The y-intercept is where the graph touched the y-axis, so that would be the y-intercept. That's 0, 3. Okay, the axis of symmetry, I look for that vertex. The vertex is right there, and the line that goes through that vertex, that is called the line of symmetry. Notice the line of symmetry, the x is 2. So that means x equals 2. That is the line. So the axis of symmetry is x equals 2. That's my axis of symmetry. The vertex is at 2, -1. Okay, so that's the vertex. These are the x-intercepts. And that is the y-intercept. Okay? For this graph right here, which is an absolute value graph, absolute value function graph, here is my vertex. It is also my x-intercept, which happens to be 4, 0. My y-intercept is over here at 0, 4. The axis of symmetry is right through the vertex, so it's this line right here. So that is x equals 4. And my vertex is at 4, 0 at the x-intercept. Pretty neat, huh? And I think that is it for this review. Make sure you also learn the type of rotations, the type of symmetries. This is bilateral symmetry. In another page, which I think I gave you, which is the family of functions, it shows you the type of symmetries. Sometimes you have rotational symmetry, sometimes you have bilateral symmetry.